Have you ever imagined that one day high-speed bullet trains would be able to run at 155 miles per hour under the sea? Well, you may be in for a surprise. In recent years, China has already earned a reputation for outstanding infrastructure, but now they are pushing the limits of infrastructure development even further by building the longest submarine high-speed railway tunnel in the world. There is no slowing down in China's high-speed rail ambitions. China's investment in high-speed rail, which also includes the development of the world's fastest trains, is part of its massive infrastructure spending program. From an environmental perspective, China is investing more and more into train travel in order to cut down on CO2 emissions from both the automotive and aviation sectors. According to a study published in 2019, data shows that high-speed rail significantly reduces environmental pollution by 7.3% in China. So China's bullet train network is fast expanding, and it will soon extend under the sea. China is investing $4 billion to build the world's longest undersea high-speed rail tunnel, and they named it the Jintang Undersea Tunnel. Connecting Ningbo, a port city south of Shanghai, and Zhoushan, an archipelago off the east coast, the proposed underwater tunnel will be a part of the 50-mile-long Yangzhou Railway plan to boost tourism and create a 2-hour commute zone within Zhejiang province, with a length of 10 miles and a maximum tunnel depth of 48 miles. The engineering difficulties are enormous. This has never been done. Are they crazy? Let's dive into an unbelievable story. The plan. On a cold day in November 2018, after first being mentioned in a government transportation plan in 2005, the feasibility study of the plan was finally approved by Beijing. The construction will bring China's ability to design bridges and tunnels to a new level. According to Zhang Xiaoyong, chief designer, the Ningbo-Zhoushan Railway will support trains operating at 155 miles per hour. When completed, it will shorten the travel time between Ningbo and Zhoushan to less than 30 minutes, which is a quarter of the present duration. It is set to be a railroad project which will facilitate high-speed trains as well as vehicles. Currently, the world's two longest undersea tunnels are the 33-mile Seikan Tunnel in northern Japan, of which 14 miles is beneath the sea, and the 31-mile Channel Tunnel between the United Kingdom and France, 23 miles of which is under the sea. But this is something different. One of the most noticeable features of its construction is the multi-section tunnel mouth docking. Trains and vehicles will travel across the sea via two separate tunnels. This peculiarity distinguishes it from other submarine tunnels throughout the world and adds to the project's difficulties. Extensive planning and engineering knowledge are required for the precise alignment and connecting of several parts of the tunnel mouth. The complexity of this technique has contributed to the Jintang Undersea Tunnel's reputation as the most difficult undersea tunnel building project to date. The Hong Kong-Zhuhai-Macau Bridge, a modern engineering marvel that was completed in 2018, acted as a forerunner to the Jintang Undersea Tunnel. However, the complexity and scale of the tunnel will overshadow the bridge's accomplishments. The Jintang Tunnel, with a length of 10 miles, will be a significantly more difficult undertaking. Its 45-foot diameter, along with a maximum buried depth of 48 miles, poses considerable obstacles that necessitate creative solutions. Different from the 4-mile-long immersed underwater tunnel of Hong Kong-Zhuhai-Macau Bridge, this underwater passage will be a shield tunnel and placed deeper in the seawater, which will create multiple difficulties for the construction crew. As soon as the news of the plan came out, engineers believed it was an impossible project. The challenge. But the Chinese persevered. On May 1, 2019, the drilling engineering of the tunnel started. During construction, several major challenges had to be overcome. Apart from facing the sudden outbreak of the COVID-19 pandemic, when construction temporarily had to be suspended, one of the major obstacles were the geological conditions of the area. The tunnel passed through a mountainous region, characterized by complex rock formations and varying ground conditions. Excavating through such challenging terrain required extensive geological surveys, careful planning, and specialized drilling and blasting techniques. Another significant challenge was managing water inflow during the construction process. The tunnel traversed areas with high water tables and encountered underground water sources. Implementing effective dewatering systems and waterproofing measures was crucial to ensure the stability of the tunnel and prevent flooding. Additionally, the construction team had to address the issue of ventilation as the tunnel lengthened and the underground space expanded. Ensuring proper air circulation and ventilation became essential for worker safety and maintaining optimal working conditions. Logistical challenges were also prominent. Transportation of construction materials, heavy machinery, and equipment to remote mountainous locations posed logistical difficulties. Building access roads and establishing suitable infrastructure for the construction site required meticulous planning and coordination. Of course, ensuring the safety of the construction workers was a priority. Working in confined spaces, dealing with potentially hazardous conditions, and implementing comprehensive safety measures were vital to mitigate risks and accidents during the construction process. But that wasn't all. By far, the most difficult challenge in building the Xintang undersea tunnel is overcoming the tremendous water pressure at such depths. The seabed pressure reaches an astounding 1.0 megapascals at 78 meters below the sea surface. To put this in context, the Hong Kong-Zhuhai-Macau Bridge was built with a maximum pressure of only 0.8 megapascals. Previously, the most advanced tunnel construction technology in China could only withstand a pressure of 0.7 megapascals. As a result, China had to make amazing technological advances to secure the tunnel's safety and stability in the face of such harsh conditions. Construction. The construction crew used a variety of ways to adapt to different soil and rock conditions throughout the tunnel path. Depending on the geological conditions found, open cut, shield, and mining techniques are used. The open cut approach is used in regions where the soil is soft and flexible. This entails excavating the earth directly, building the appropriate support structures, and then replacing the ground once finished. When Chinese engineers built the undersea tunnel of the Hong Kong-Zhuhai-Macau Bridge, they used the construction method of immersed tubes. First, the immersed tube tunnel is built on land. Then the immersed tube is placed on the seabed, and finally sunk into the seabed and spliced in sequence. The Xintang undersea tunnel adopts the shield method. This method is used in places with softer and water-bearing strata. In these situations, shield machines are utilized to excavate tunnels. As it progresses, the shield machine gently protects the surrounding rock, while transferring excavated soil, gravel, and muck through a conveyor belt. This technology assures stability while minimizing the impact on the environment. In places with complicated geology and layers of hard rock, the mining method is important. Drilling and blasting are used in the mining procedure to excavate the tunnel segment. Because of the greater risk of tunnel collapse, this method necessitates more cautious and meticulous excavation and repeated rounds of controlled blasting. By combining different building approaches, Chinese engineers display their adaptability and versatility in tackling the various geological problems encountered along the length of the undersea tunnel. This integrated method allows them to properly navigate through various soil and rock conditions, assuring the successful completion of this groundbreaking project. Since March 2020, the Maritime Department has helped the project resume smoothly through innovative service measures such as online review and cloud supervision. The patented product of the 4th Railway Institute, the Geological Exploration AI Management System, has also shown its talents. The system has functions of drilling hole positioning and full monitoring of the drilling process, which can realize zero-contact remote supervision and effectively avoid the risk of epidemic situation caused by human contact. Future. Despite all the challenges, the construction of the Xintang Tunnel is well underway, showcasing the determination, expertise, and innovative techniques employed to overcome the complexities and deliver a vital infrastructure project. Expecting to open between 2025 and 2028, the tunnel's successful completion will mark a significant milestone in China's infrastructure technology. China will display its engineering expertise and strengthen its status as a leader in infrastructure infrastructure development. By overcoming the problems posed by high water pressure, China's ability to innovate, solve complicated issues, and achieve the extraordinary are demonstrated through ambitious projects such as the Xintang undersea tube. After completion, the world record will be set. So, are you curious about other breathtaking projects like the immersive Hong Kong-Zhuhai-Macau Bridge we mentioned earlier? Check out this deep dive where we'll show you all about it and why it created such a significant impact. Thanks for watching, subscribe and like this video.